Hi, this is Sree from Techie Talks AI. Today's topic is on RAG, Retrieval-Augmented Generation. This video is going to give you the clarity that you need to understand why there is RAG and how it works. So let's try using my way of teaching, that is Sree's way of teaching. So welcome, let's get on. I have prepared the notebook, that is Jupyter notebook using Google Colab. So here, like I mentioned in my previous videos, I have already added my Google Gemini and OpenAI API keys here. First, what you are going to do is we are going to query the large language model asking about my company. So question is, what is your company name? So let's run and see. See what it says. I'm a large language model. I'm trained by Google. I don't have a company name. See this? So in this video, what we're going to see is how we can add our local knowledge along with the query so that we can ask questions about our local knowledge. So next experiment is no retrieval augmented generation, but we are providing the full knowledge base without any chunking or similarity search. Okay, so let's see what it is. So here, this code is similar to our previous code, but here what we are going to do is we are going to load a string containing our local knowledge, which has the company name and company related some information about my company. In production scenarios, we will be loading this knowledge from a text file or some database or from a remote URL, etc. Essentially, this is a large collection of information about your product or services or your company. So we are simulating it with the help of this knowledge string. So what do we do then? This knowledge string has information about our company. Clear? Let's now move on. So in this system instructions, what we're going to say is, you're a helpful assistant. You will answer only from the following text, and we provide the knowledge. And here we have the query, how many AI chatbot consultants. So here we have the query, how many AI chatbot consultants do you have? Okay, so let's run and see. Okay, so based on the provided text, there are two AI chatbot developers, Abhijit and Sree Prakash. This text does not refer to them as consultants. Okay, that is fine. We can even ask developers, do you have? So essentially what this demonstrates that we can send query to the large language model along with our knowledge so that the large language model will reply back to us with the relevant information picked up from our knowledge. But is this efficient? Every query that goes to large language model will also have the entire knowledge text. So this is not an efficient way because it uses large number of tokens. It takes longer time, and also the response may not be accurate because we are sending too much information which may not be relevant for the query. Clear? So what do? We do an operation called chunking. So here I am demonstrating chunking with the help of a function, load and chunk knowledge base with overlap. So here I have defined overlap 2 and chunk size 10. Let's see how this works. Let's run it. See, now the knowledge text has been split into separate elements in this array called chunks. You see this? So here, this is the, say, chunk 1, and here we have chunk 2. And if you notice that this chunk 1 is ending in cutting edge AI. See this? And chunk 2 starts with cutting edge AI. So there is an overlapping in these sentences. You see this? This overlapping helps us to maintain the context, or the meaning of the sentence is not lost by abruptly cutting these sentences. Okay, so that is one way of chunking, but later on I'll make a video on different types of chunking that are possible. So what we have done now is we have split the large knowledge into smaller units. But what is the point? Let's see. What we will do now is we will demonstrate how chunking is used, okay, for retrieval augmented generation or RAG. So I have made a demonstration. So we will create a small chunk for demonstration which has got dog, swim, water, and bark. These could be sentences, but for simplicity, we are just using meaningful words. It has got 4 elements. Now what we will do is, we will convert these chunks into embeddings. Embedding is a vector. We will use the embedding mechanism provided by these large language model providers. OpenAI has it, Google also has it. In this case, we are using Google's text embedding mechanism. And here, I am deliberately using dimension 2. So that is, each word will have a vector in a 2-dimensional space. So that vector point is marked by 2 dimensions. So in this case, x and y. So dog will have an x and y, swim will have an x and y, water, bark, all these will have x and y. We will see what they mean. So let's run it. Okay, so it prints an array. Okay, so if we simply print it, it'll come one below the other. So let's see it. Okay, so let's comment this print and see how this embeddings look. So here, see the first one, this x and y is for dog, next is for swim, third is for water, and then we have one for bark. Now, let me try to help you visualize this. What we will do is, we will plot it. Let's run this to see this in a 2-dimensional graph. So here, if you see, we have dog here, bark here. They're relatively nearby, right? And then we have swim and water are close as well. So the embedding looks at the chunk elements and accordingly creates vectors. In this case, we have 2-dimensional vector, but in production, we will use large number of dimensions. Like OpenAI's text embedding has got 1536 coordinates. Okay, so which we cannot visualize, but each chunk will have 1536 coordinates to represent its meaning. So now, how do we use it? Supposing you are querying about, say, swim. What it will do is, it will see which point in the hyperdimensional space that is closest. Is this, and then it will pick the closest element. Okay, so we have control over how many elements it should pick, etc. But this is the idea. Is that clear? So I'm going to demonstrate how this works. So what we're going to do is, we are going to query the embedding. I have a query text which is swim. So what we need to do is, we need to convert this query into a query embedding, so that that query also gets a vector coordinates. So make sure that the dimension for that query vectorization also is same as your embeddings vector dimension. So here, let's run it. So now we have the query embedding ready from the query text. Okay, so now what we're going to do is, we are going to do a similarity search retrieval. So what we will do is, we will call this function, which is called retrieve relevant chunks using cosine similarity. We don't need to go into the calculation behind it, but the idea is, it will find out the closest embeddings in the vector space. Okay, so, and after it gets the indices of those points, it will use the chunks to get the words back. That is what it's doing here. So here it is combining the relevant chunks from the vectors. So